All right, so welcome everyone to our free GMAT prep hour. My name is Dmitry Farber. I'll be working with you today. I've been teaching with Manhattan Prep here in San Diego for 10 years. So I've been doing the actually, I first taught the GMAT in 2000. It's been almost 20 years. That's frightening. Okay, so I've been doing the GMAT for a while. I want to talk to you today about estimation. And specifically, not just how to estimate on a problem when you're stuck and you don't know what you're doing, but how estimation can help you even on a problem that you know how to do and that you're going to do correctly. So let me ask you this. Why is it that we want to estimate? Why would we ever want to estimate? If I'm going to do the algebra, if I'm going to pick smart numbers, if I'm going to, set up a chart or something like that, why would I want to estimate an answer to the question when I'm doing something like that? Any thoughts? Uh, okay. Saves time, less number crunching, saves energy. I might be able to get the answers out quickly, right? Helpful when I don't know, right? Okay, so one answer to this is that estimation is fast, right? At least ideally. For some people, it is not at all fast. And I have to be careful. I don't want you to estimate if it's not helping you, right? But estimation can be fast, right? Sometimes it works to get us an answer when we don't have another approach. But what about when we do have an approach? Because someone could argue, well, it's not fast. If I'm going to do the algebra anyway, it doesn't seem very fast to estimate first, because why not just do the algebra, right? I remember I used to teach third grade, and they would make these worksheets, and it would look something like this. They'd give you a problem. They'd do like 297 plus 312. Okay, I'm sure you all know how to do that problem. I really hope. And they would have something like this. It would say estimate, and then it would ask for the answer. And the idea was supposed to be that the kid would go, oh, well, let's see, 297 is about 300, and 312 is about 300. That's 600. And now I'll actually do the answer. Okay, 2 plus 7 is 9, and 9 plus 1 is 10. Carry the 1. Okay, I have 609, right? But some of the kids who were kind of smart wouldn't do that. You know what they would do? Does anyone have an idea what sneaky thing they did to make their lives easier? Put yourself in the shoes of a slightly lazy but also somewhat clever elementary schooler, right? Well, not even just rounding. What they would do, since they knew I was going to ask them to do both, or the worksheet was asking them to do both, I didn't personally ask them to do it. No, even different. That I guess it was a very open-ended question. They would simply write 609 as their estimate. Why? Because they don't care about estimation. They just wanted to fill out the sheet as soon as possible and go play. And so they would do the problem and get 609, and they put the answer as 609, and they think, first off, now I haven't had to do the problem twice. I've had to do it once. And second, look how smart I am. My estimate was exactly correct, right? And so it's hard to say they're wrong, right? If I said, what's, estimate 2 plus 3, you'd say, well, it's about 5. How close to about? Well, it's exactly 5. There's no point of saying 2 plus 3 is about 0 or about 10. It's 5, right? And so the idea is, if the question is that easy to do, maybe it makes sense to estimate. And even with a harder one where they had to do a lot of carrying, or maybe where they made a mistake, they wouldn't want to estimate. They'd rather just do the problem. But the thing is, they were kind of cheating themselves, because later on, when you have a problem that is really hard to do, you might find that estimate's the only way to get there. But there's another thing. Okay, and so what I'm getting at is it can be faster to estimate, but it's not always faster, because here, to think of 297 is about 300 and 312 is about 300, so it should be a little more than 600, because this one's 3 under, that one's 12 over, and 12 minus 3. To do all that is extra work, and if I'm going to do the addition anyway, why would I want to do that extra work? But there's another thing. Estimation helps us to catch our errors. And this is one of the most important things, I think, on the entire test. We need to catch more errors, right? So estimation helps us catch errors even when we, have a good approach. How often are you, whether it's on the GMAT or just in life, how often do you do some work and realize it's wrong because it doesn't make sense? It doesn't fit your estimate, right? I think about the guy who drove across Iceland. There's this guy, he landed at the Reykjavik airport, and Icelandic names are kind of tough to spell if you're not from Iceland. And he punched in the name of his hotel, but he did it quite a little bit wrong, and his phone ended up navigating him across the entire country of Iceland. So he's driving and driving. It's about a 6-hour drive. At some point, you think he should have said, I don't think my hotel was this far away from the airport. I'm pretty sure my hotel wasn't 6 hour drive away from the airport, and he should have caught that. And so by having an estimate of how long does it usually take to drive from the airport to the hotel, you compare that and say, wait, something's going wrong, right? And so estimation is incredibly helpful with that, because we catch our mistakes. I catch a lot of mistakes, and I make I'm really good at the GMAT, but I make a lot of mistakes, as I think most of us do. But I catch a lot of them for a really dumb reason. And I catch a lot of my mistakes because I already know what the answer is, which is not very helpful to you on the GMAT unless you're cheating in some way, right? You won't know the answer already. But what I mean is, in class, if I'm doing some work and I go, wait, that's going to give me 3/5 and I was supposed to be 5/3. Where did I flip it? Oops. Oh, right. I have to fix that, right? I notice those things. Now, on the test, I'm not going to know it that well, but if I have an idea what kind of answer I'm looking for, it allows me to get an idea, to catch some of those mistakes. And this is really common because a lot of people tell me, oh, I make a lot of careless errors, or, oh, I missed this problem and I shouldn't have missed it. And those are really important. I am more concerned about the problems I miss that I completely know how to do than the problems I miss that I don't know how to do, which might sound weird, but the idea is that on the test, since it's an adaptive test, if you're missing the problems that are easier, that totally make sense and you know how to do, those are going to hurt you more than the problems that are obscure, difficult, weird, anything like that. So it's very important to get solid and reliable at the easy and the mid-level problems. And that's much more important than getting a single of the hardest questions right. On our CAT exams, we'll categorize things as like 3 to 500 level, 5 to 6, 6 to 7, 7 to 8. I don't care if you get any of the 700 to 800 level right. Even if you're trying to get a 700, I don't care if you get those right. What I care about is if you get the things below that level right. And so estimation hopefully will get you doing some of that. If you get to the point in your studies where data sufficiency finally makes sense and it's great, and you're getting knocked off on problem solving, estimation can really help you there. Okay. So let's look at some problems. You may have seen some of these before, since they are from MBA.com. But what I want you to be able to do is think about quick ways to knock out some answers. So I'm not going to give you a lot of time on any one problem that we do. I'm going to focus much more on just why we're doing it, right? Question, if my goal is 700 plus, is my goal to get every 600 level question right? It's tricky. In the end, I mean, those categories that we're using in our tests aren't exactly real categories. There's not exactly such a thing as a 600 to 700 level question. But to some extent, yes, you want to get the middle of the road and the somewhat harder questions right. Depending on how your verbal section is versus your quant section, that complicates things. It also matters what your accuracy is above that level. Are you really not getting any of the hardest questions right, or are you getting some of them right? So it's not a perfect exact thing. There's more than one path to success. However, generally speaking, yes, you want to get the problem, you want to get very, very solid at the problems kind of below the level you want. And not necessarily the problems at the level you want, if that makes sense. The GMAT's goal is to try to hold you to a point where in quant, you're getting about 4 out of 7 right. You're getting a little bit more right than wrong. And if you're getting 4 out of 7 right, which is about 57%, that's kind of where you want to be. If you're getting less than that, often that's because you're not letting the algorithm do its thing. You're holding on and trying to do problems that are too hard, and maybe you get some of them right, but then they just give you another hard one and another hard one. You end up with your accuracy being too low because you run out of time. The other way people don't get to 57% is if they're just not there yet in their practice yet, where they're like, even the easy questions are too hard. But once you get past that easy level, most people should be getting 4 out of 7 right. Okay. Let's try a couple of things here. So here's a problem from MBA.com. And all I want you to do, I'm going to give you about 30 seconds. And if maybe you can solve in 30 seconds if you're super fast. But all I want you to think about is what answers are reasonable, what answers aren't reasonable. So go ahead and give this a shot. Okay, go ahead and chat it in. What do you think are the best answers? What are the answers? Just put in the letters of the answers that you think are most likely to be correct. If you think you know exactly what the answer is, that's fine. But put in the best answers that you see, and then we can talk about why. Okay, I'm saying B, I'm seeing D or E, I'm seeing A, B, C, B, A, A, B, C. Okay, so we've got all the answers covered. That's a good sign of some controversy, right? Um, so how do I figure out what this is likely to be? Obviously, I can do the math. I can find out what 2 plus 1/3 is, and I can divide 1 by that, which means flip the sign, and I can add that to 1, and I can flip it again. It's just a couple steps. But it's not terrible, right? It's not a terrible problem that none of you can do. In fact, I would imagine that most or all of you can do this problem if you've been practicing your fractions lately. But it's useful to acknowledge that when I'm doing a problem, that it's very easy to make a mistake. I might flip something wrong or add the wrong thing or miswrite something. The other day I was watching someone do a problem, and instead of the problem said 32, and they on their paper they wrote 30. And so then when they factored the 30, they had a 5 in there, and they should have had all 2s, right? Did the student know that 32 doesn't have 5s in it? Yes, but he wrote down the wrong number, and that got in his way. So we're always looking for like ways to catch our error. So what do I know about this number? I'm dividing 1 by something. And what do I know about the bottom compared to 1? What do I know about the bottom, the denominator of this fraction, compared to the top, the 1? Yeah, the denominator is in the top. Now I'm seeing someone say 7 should be in the numerator. That's interesting, and you may well be right, but that's only if you do all the work. And if you can do all the work that fast, that's fantastic, but we can't all do that. It is interesting that there are a lot of 7s and 3s in this number. The 3s are not surprising because there's a third in the problem. The 7 might be slightly more surprising, but if you do 2 and a third and know it's 7/3, you might expect that there's a 7 somewhere. Um, However, a simpler thing we can do that's less rigorous maybe, but still really valuable, is to say, hey, I've got 1 over 1 plus something, and just that alone means I've got 1 over more than 1. So what answer choices does that immediately allow me to rule out? Yeah, right? The denominator is more than 1. And so you could say it's a reciprocal of that, or you could simply say that when I divide anything by more than it, so if the top, notice if the top were 7, then it wouldn't exactly be the reciprocal because I'd be flipping and multiplying by the bottom. But the point is, if I have 7 on the top and more than 7 on the bottom, or a million on top and more than a million on the bottom, you know that that fraction is less than 1, right? Imagine that the fraction were something like this, 26,000 over 26,000 plus 3 pi. Now, I don't know what that is. I don't know how to simplify that. That's awful, right? But what do I know about it? It's a little less than 1, right? Because 3 pi is about 9 or 10, right? Closer to 9, I guess. I know that it's not much less than 1, but still I know that it has to be less than 1, right? So here I can say, all right, so that means this is less than 1. And so I can immediately get rid of D and E. Now, narrowing it down is not necessarily the point, because again, if you're going to do the work, you don't need to sit there and get all the way to an answer this way. But there is a way to get closer to a right answer here. And that's to think about, okay, so what do I have on the bottom? Now, one annoying thing, of course, is that we have a fraction within a fraction within a fraction. We have a third on the bottom of that 1 over 2 plus 1/3, and then that's a fraction, and then that's a larger fraction. It's too many fractions. So what if I cut some of this out? What if I had something like, what if I just had 1 over 1.5? What would that be? What's 1 over 1 plus a half? 2/3, right? Because we got 1 Some of you are like, I just got into this, I don't know. Right, 1 over 3 halves, right? 1.5 is 3 halves. And you flip that and multiply. It's 2/3, right? If you haven't flipped and multiplied in a while, that's what we're doing. When we divide by a fraction, we flip and multiply. Okay, so we could say, all right, well, so that's in the neighborhood. 2 1/3 is not that different from 2, right? So one thing we could say is this should be pretty close, right? It's not too far off. Just like if I say, hey, 26,000 plus 3 pi is really close to 26,000. It's 9 pi is not very much. Not 9 pi, 9 point whatever, right? 4 2 something, right? Is not very much. So basically that number is 1, but it's just slightly less. So I could say, all right, this should be pretty close to 2/3. So if I look at my answer choices, I could probably get to the answer right now, because look, 3/10 is way less, right? 2/3 is like, 0.66 if we think of it as a decimal, right? This is 0.3. Is it going to be half as much because I added a third? No, there's no way, right? Is it going to be this with 6/7? That's like about 0.86. That seems a lot bigger. I'm not too keen on that, although I can see someone picking it, right? It's not crazy. It's better than A. But B makes more sense. And we can get a little closer if we say, well, this is a little more than 0.6. So let's see if we can justify this, at least in retrospect. Why do we want our answer to be more than 2/3? Why is B right? And it is. Why do we want our answer to be more than 2/3 without doing all day the flipping? So because of the extra 1/3, but so we have to think about what this happens. And sometimes this is where our mind explodes and where people go, forget it, I'm not estimating. It's not worth it to me, right? But if we think about it, we could say, well, 1.5 would give me 2/3. Now, what happens if I make the bottom bigger, right? That should make my fraction smaller. And if I make the bottom smaller, it should make my fraction bigger, right? So I have to kind of think from the inside out and say, well, if I make this bottom bigger, that's going to make this fraction smaller. And if I make this fraction smaller, it's going to make the whole bottom smaller. And that's going to make my number bigger, right? So that takes a little thinking for sure, right? And we could be forgiven for saying, forget it, I'm going to do all the math. And that's fine. We might already be down to B or B and C or A, B and C, and then we just do it. But at least we're going to have a check so that if we accidentally don't flip correctly and we get 10/7, which someone's going to do, that's why it's there, we're going to catch that. And so we're just catching some of the more common errors, right? It's just that you think about all the things they do to make sure that we don't get into accidents when we're traveling or when we're driving, right? We have traffic lights, and we have lanes and the bumpy things on lanes that alert you when you're going off, and people can honk at you if you're not noticing that you're about to crash into them. And there's all those systems. And when you're in a plane, the pilots are cross-checking with each other, and they have a navigation system, and they're talking to the flight tower. We're doing all these things because we really don't want to crash, right? And so it's not life and death whether you get this question right, but we want to, if we can add little things in that aren't too taxing, that increase our accuracy, that's a really good thing. So we can say, hey, 1/1 plus, 1/2, more than 2, right? I'm going to call it 2 plus, right? It's a funny way to say it. I'll put that in quotes, right? Tell me if I'm losing anybody. If you think I'm crazy, that's okay. You can adjust, right? Then we're really saying, okay, so that's 1/1 plus less than a half. And sometimes I'll write these like little inequalities and something, right? Less than a half. And so that's 1 over less than 3 halves. So if I divide by less than 3 halves, I'll get more than 2/3, right? And that might not be very intuitive to you if you just flip it, because less than 3 halves isn't a real number, right? I can't say, oh yes, it's less than 3 halves, that's a thing. But the idea is if you divide by something that's less than 3 halves, you'll get something that's more than 2/3. Okay. Questions, thoughts, fist bumps, anything? How are we feeling about this? Feeling all right? Okay. So the general category of estimation that, you know, I would sort of, I would put this in, right, is sort of high-low, you know, what effect does this have, right? So we could call this high-low estimation, you know, is this a bit more or a bit less than some benchmark? Benchmarking is really important in estimation because we're saying, hey, you know, what's close to this, right? What's something that's easier to work with, and then is it a little bit more or less, a little less than that? The kid who's doing 297 plus 312 might go, oh, well, I know 297 is a little less than 300, and 312 is a little more than 300, but 12 is more over than that 3 is under, so it should be more than 600 when I add those up, and then they should, if they get something different, they know they made a mistake. Right? Because I see even adults who know better doing things like, you know, kids would do something like this. They do 300 minus 122. And obviously, I'm really hoping you all know not to do this. But they'd get an answer like this. Now, the kids didn't know better. They're just like, I don't know, I can't do 0 minus 2, so I'll just do 2 minus 0. Like, this is bad, right? Adults know better, but sometimes they still do that because they get thrown. And then again, if I know that my answer should be less than 200, I'm going to notice when I make that kind of mistake. Okay. So let's try another estimation. What do we know about the value of 10 times 1 minus 1 divided by root 3? And what I'd ask you to do is put in your best estimate for this. Please don't give me a precise answer. It's going to be ugly. Don't get out your calculator, right? But give me an estimate for this. Don't look at the chat if you're not ready, but when you're ready, put it into the chat and let's see what people think is a reasonable value for that. Okay, 6, 6.5, something negative, negative fraction, 5. Okay, so how can we reason about this? We know it's 10 times something. 10 helps us move, you know, a decimal place. So what do we know about what's inside? One thing I would think about, because we're talking, so a lot of people are giving me positive numbers and someone else is giving me negative numbers. So we want to think about which is bigger, 1 or 1 over root 3. So what do I know about root 3? What do we know about that number? It's an irrational number, so I don't know what it exactly is, and neither do you, because it keeps going. And so at some point you can just tell me it's root 3. Right? In math class, when they ask for a precise answer with root 3, it's going to have the number root 3 in it because anything else is an estimate, right? Everything else is an approximation. Root 3 can't be 3, right? Because it has to be something you multiply to get 3. So what do I know about root 3 in terms of its range, right? I know what root 4 is, right? I know what root 1 is. That's really valuable to know. Root 3 has to be bigger than 1, right? Because we know that root 1, get rid of this joke here. We know that root 1 is equal to 1, and root 4 is equal to 2. So root 3, of course, has to be in between those, right? It's got to be bigger than 1. Otherwise, when we multiplied it, it wouldn't get bigger, right? And it's got to be less than 2, so it's like 1 plus. It's 1 and change, right? And since it's closer to 4 than to 1, you might not surprise you that it's more than 1.5, right? 1.5 when you square it is 2.25. That's too small. A cool mnemonic that I learned one time, I'm going to color code this. If you, bonus points if you know why I'm color coding these. I haven't put the root signs in yet. Anyone know why I'm putting these particular colors on here? This is really corny, but it works. And that's all I care about this test. I care what works. I don't care how corny it is. You know, if it helps you for your self-esteem to stare in the mirror and tell you how smart you're, tell yourself how smart you are. If you think that's corny, too bad. Do it if it works, right? If it helps you to do jumping jacks in the break, during your break, do it if it works, right? So these are corny, but they work. So what are 214 and 317? Well, they're holidays. Anyone seen this before? Helps if you happen to celebrate these particular holidays. If you don't, then obviously you're less likely to know them. But if you're really funny, you could use these to remember the holidays. You're like, oh, I always forget Valentine's Day, but I know it's a square root of 2. I'll always remember, right? But it's having those approximations is really useful. But we don't have to know that approximation to know that it's between 1 and 2. Okay. So what I now know, though, is I've got 10 times 1 minus 1 over 1 something, right? So I could say, all right, well, let's think about the extremes, right? On the one hand, I could have 10 times 1 minus 1. Okay. That's 0, right? And then I could have 10 times 1 minus 1/2. Now, can we agree that 1 over root 3 has to be more than a half? Are we cool on that? Right? If I divide, right, since root 3 is less than 2, when I divide by root 3, I get more than 1/2. Right? So if I divide 1 by 1, I get 1 minus 1 is 0. If I divide 1 by 2, I get 1 minus 1/2 is 5. When I divide 1 by something in between, like root 3, I'm going to get an answer between 0 and 5. And what's it going to be closer to, 0 or 5? Oh, my thing is freezing. I'm going to pause this for a second. Hey, everybody. Sorry about that. Zoom decided to lock me out in the middle of the workshop. So what I was asking, I think I froze for a minute there on yes, so I won't be able to bring that back up. But can we all agree that if I divide 1 by a little less than 2, I get a little more than 1/2? Everyone at peace with that? All right, cool. So if I have that, then I'm allowed to now make this inference that I've got a little less than 5, right? Not a lot less than 5. The answer is really close to 5, right? So if you were in the neighborhood of 5 or 6, that's kind of what we want, because we're saying, hey, 10 times 1 minus a half is equal to 10 times 1/2 is 5. 10 times 1 minus, you know, something that's less than a half is going to be 10 times, sorry, something that's more than a half. Is going to be 10 times something a little less than a half. So that's going to be less than 5. So if you said less than 5, you were really close to an exact answer. That's the kind of thing we're looking for. So that's one style of estimation, is to use a nearby benchmark, use something simpler, use something you kind of do know, and narrow it down, right? It's a thing we do all the time in daily life, probably. If you're saying, all right, you know, I bought a bunch of items that are $3.99, basically that's $4, right? Or if it's taxed, it's a bit more than $4, okay? And even if some of them are like $3.75, you're in the neighborhood, right? I know that roughly, you know, I can buy 25 of them for $100, give or take a little bit, depending on how much under and the tax and all those things. So I have a sense of where I am. You know, you probably know roughly how long it takes to fly across the country, right? You have an idea, and if you've been to one place, you kind of know, right? If I've been to Chicago, I maybe know how long it would take me to get to New York, roughly, give or take a little bit, right? And so we want that, we don't want to like turn that stuff off that we use all the time on the test. Okay, let's try this on another problem. Again, this official one from MBA.com. Give this a try. And 30 seconds, just put in the most likely answers. Oops, sorry. All right, so I'm seeing an interesting split between folks who are going for positive answers and negative answers. So let me ask you something. Which is bigger? If x over y is 2/3, which is bigger, x or y? Y, right? So I can say, all right, I can write this as x equals 2/3 y, if I want, and substitute in, or y equals 3/2 x. And obviously, then if I know that, I could substitute that in, and that's fine. And this is not that hard a problem to do if you know how to do that, and just substitute it in. But I could also just say, hey, what happens if I take x and I take away more than x, and then I put it over x, right? What's going to happen? Well, what happens when I take x minus more than x? What am I going to get? Right? I'm going to get a negative number, right? So I know I'm going to have a negative over whatever x is. Now, depending on the negative number, if I didn't know anything about x and y, I would have no idea what kind of fraction to get, because I don't know if it's going to be a little more, and so it's a little fraction, or if it's like a negative, you know, maybe it could be negative a million or something like that, right? But I know that it's negative, and since x is not negative, that I can see, then it seems like I want a negative number, right? Now, it's interesting to think about whether x could be negative, right? We can deal with that in a minute. There's actually a reason that it's still okay to not worry about that. But right now, I can get rid of all three of these. Now, at this point, I could also just say, hey, I could have just done it, right? I could say, hey, x minus y over x is equal to x minus 3/2 x over x. And here's why I don't really care if x is positive or negative, because I can just cancel x out of the equation. Boom, 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 right? This turns into 1, of course. And now I have 1 minus 3 halves over 1. And now it doesn't matter what x is because everything is, you know, in terms of these relationships. Negative 1/2 over 1, of course, is just negative 1/2, and we're done. So this was not a really difficult or time-consuming problem to do outright if we knew the approach. But even still, having an estimate, even if I take 10 seconds to sort of look for these things, it makes it more likely that if I do something wrong, which I do all the time, then I'm more likely to catch it. Notice also, by the way, some people will read this incorrectly. Some people read ratios and they'll say, oh, x is 2 and y is 3. Now, we're all so sophisticated, we know better, right? If I said something like, you know, the ratio of women to men in our country is, you know, 26 to 25, in no way are we saying in this country there are 26 women and 25 men. That's silly, right? That's just the ratio. But it still works if I want to think about relative things. I can still do it. I can just pretend x is 2 and y is 3 and say, oh, 2 minus 3 over 2. And that's another way to get to the problem in this case. And the reason I can do that is that, sure, x might not be 2, x might be 4. But if x is 4, y is 6. 4 minus 6 over 4, it's going to be the same thing. Right? 6 over 9 minus 6, same thing over and over again. So it doesn't matter what numbers I pick as long as they fit in. So I can plug numbers as well. So I got lots of ways to do a problem like this. And again, my goal, you know, some of you are already feeling pretty comfortable with math and you might think, oh, I didn't need to come to a workshop to talk about a problem like this. I know how to do this. But the idea is not, do you know how to do this, but are you looking for these alternatives? And if you can't do it on a problem that you do feel comfortable with, what are the chances you're going to stop and do it on a problem where you're feeling a little overwhelmed? So getting in the habit of looking for this is really valuable. One student I had who got ended up getting a really good score despite a lot of struggles. One exercise he did that was really useful was he went into the problem solving section of the official guide. And he just went to the very first page of problem solving. And he would just do one page, pencil down. Just what can I do other than doing the algebra? What can I do other than doing the full solution? Or sometimes he'd start working his pen, but he'd say, I'm not going to do the whole thing. I'm going to look for something different. And sometimes he couldn't find anything, and neither can I. So I had a student asking me a problem yesterday that was like, all I could see to do was this really ugly algebra. And as far as I know, there's no like really clever way to do it faster. And that happens. But in a lot of cases, there is something we can do. And if we get in the habit of looking for that, we're going to find it often. Right? And that's kind of what we're looking for. Okay. Now, this can also help you on more involved problems where it might take more of an investment up front to even know what they're talking about. So I'm gonna do two things. I'm gonna upgrade to word problems, and I'm gonna give you 2 at a time. And I'm only gonna give you 1 minute and 20 to narrow down answers for both of these 2 word problems. It's not nearly enough time unless you're super fast at this stuff, right? 1 minute and 20 is not long. But all I want you to do is say, what answers are reasonable or unreasonable, in which case, how do I narrow it down? Okay, so let's try a couple of word problems. All right, so let me know what you think on the first one. What are the most likely answers to the top problem with the table? 4, 5, 4, 5, 5. Okay. It's interesting because it's a two-part problem, and so we have to think about both parts, and that complicates things. But I want to talk about that too. What about the second problem? What do you think are the most likely answers on the second problem? If people look at the second problem, or you only had time to look at the first one? Be careful if you only look at the first one. We have to think about how we're dealing with time on the test. We want to be able to move on past things. And so if the challenge is get through 2 in 120, look at something quick and say, all right, next one, and get used to that time pressure. Right? I'm seeing 100K, 200K. Okay. 200K, 500K. All right, something in that neighborhood. A lot of people liking somewhere around that 200K. Okay. Now, sometimes I estimate and it doesn't go very well, right? So, whoops, my initial estimate on this problem, very rough estimate, looked like this. Well, I've got a half and a fourth right there. That's 3/4. And then I've got the 1/5. So I know that there's less than a fourth left. Okay, so 10,000 is less than a quarter of it. So it needs to be more than 4 times that, right? So in other words, I'm saying, 1/2 plus 1/4 is 3/4. So already there's less than 1/4 left. If 10K is less than a fourth of the total, then 40K is less than the total, right? So the total is more than 40K. Now, that's not very helpful, is it? Right? I've narrowed it down to A, B, C, D, or E, right? So this is true technically, and in a very, maybe spread out problem, this might give you the answer, but I left out the 1/5 entirely, and so that's too rough, right? It would be like if you said, hey, if I worked for your company, roughly what would you pay me? And I said, well, we'd pay you somewhere in between minimum wage and $17 million a year. And you're like, well, yeah, I kind of figured that, right? It's not very precise. It's not precise enough to help me narrow the problem down. So I want to look for something else. So one thing you can do, obviously, is just do it. You can add a half and a fourth and a fifth, and that can happen relatively quickly. That's not the end of the world. And again, probably some of you did that. Maybe you even found that you were able to do this problem fast enough to have an answer by the time I asked for it. Okay, if you can do that, great. But there's another thing we can do, which is to cheat off the answers a little bit and say, all right, well, let's say a lot of you were starting around the middle and saying that it was 200,000. If this is the answer, what fraction of the total is 10K? Right, and we could ask that about any of the answers, actually. If that answer is the answer, what fraction of the total is 10K? So for 200,000, if 200,000 is the answer, if that's the amount of the trust fund, what fraction of the total does the 10,000 represent? 5% or 1/20th, right? Okay, cool. So we could say, hey, this is saying that it's 1/20th. And if I go up and down, I could say, all right, well, this would be 1/50th, right? Just 2%, if you like. Is 5%, whatever you're more comfortable with. I wouldn't necessarily write all this down, right? This would be 1/10, which is 10%. And 150 is going to be in between those. You might not feel comfortable quantifying that. You don't have to. It's somewhere between 10 to 5%, right? So we could look at this and say, hey, if I add a half and a fourth and a fifth, what's going to be left? Is it likely to be a 50th? Is it likely to be a 200th? Right, which is 0.5%, right? Is it likely to be a 20th? And here's where I can, cheating off the answers can be really helpful, because I can say, hey, 20th kind of makes sense because I got fourths and fifths and halves. Now, could I be wrong? I absolutely could be wrong. I'm not in this case, right? But I could be wrong. If you went for 200,000, you are right. And again, we can do it just by adding it up. We can say, half the total you know, half total plus a quarter total plus a fifth of the total plus 10K equals the total. And if we do common denominators, that's 10/20ths t plus, you know, 5/20ths t plus 4/20ths t plus 10K equals t. But do I want to write this equation? I'm not sure I do, because if I can see it, it's going to make my life a little easier. So from here, I can see that 10K is 1/20th of the total, and I can get to the answer that way. And there's nothing wrong with doing this. But I might sort of cut it short a little sooner if I could see, oh, wait, is it a 20th? Oh, yeah, half, 10, 15, 19, 20. Oh, yeah, but two ways I did it match up. That's a good sign. Right. So something to think about. Now, on this top one, notice that there's two aspects to this question. One is asking basically who the winner was, and the other is asking where the most votes were, right? So we have to have two different things. We can't, they don't just say which had the most number of votes total, or which had the no, you know, okay, four, right? Which had the most votes for candidate P or for candidate Q, but for the winner. So I don't think it's too crazy to figure out who the winner is. But let's say we haven't figured that out. Are there any answers that are bad choices regardless? Let's say I don't know who the winner is, and maybe I don't have enough information to calculate who the winner is for some reason. There's more still to be tallied or something. Which of these definitely are not the answer? Any thoughts on that? One, two, maybe one, two, three. So it's interesting. Like, so let's look at two. It's a good example. We can easily calculate the number of votes for candidate P and Q because it's 500. It's 50% of 1,000. It's just 500. It's half, right? So I could say, all right, regardless of who the winner is, can I get more than 500? Right? Well, let's see. In District 3, they each got 50% of a bigger number. So there's no possible way that 2 could be the answer. Can we agree on that? Because regardless of whether P1 or Q1, if you want either of them to get more votes, for P, I've got 50% of 1,500, right? And for Q, I've got 60 or 70% of these bigger numbers, right? Plus 50% of 1,500 as well. So there's no way that 2 is right. Okay, now let's compare that to 1. Clearly, if Q is the winner, then 40 is less. 40% of 800 is less than 50% of 1,000, so that can't be it. What about 60% of 800? Is that more or less than 50% of 1,000? And if that seems awkward, you can do another estimation technique, which is swapping digits, which is I could say 60% of 800 is the same as 0.6 times 800, which is the same if you swap digits here as 6 times 80. Right? I'm just moving a power of 10. This one gets one bigger, and this one gets one smaller. That's another estimation technique you can use a lot of. So that's smaller, and so we can get rid of this one. So it's not District 1. Now looking at District 3, I could say, well, let's see. If P is the winner, I wonder if that's the highest, because 50% of 1,500 is certainly bigger than 30% of a smaller number. And I think it's even bigger than 40% of 1,800, right? This is going to be like, if you do 4 times 18 is 72, it's like 720. And you do 5 times 15, it's 75. So that can't be right. So if P is the winner, District 3 is the best, right? If Q is the winner, clearly District 3 is not the best, because 60 and 70, are going to be more likely to be a good answer. Which looks better for Q? 60%. Which would you rather have? 60% of 1,800 or 70% of 1,200? Sanjana, what do you mean by less? Oh no, you were saying something else. Sorry, that was the whole thing. 70% of 1,200. What the rest do you think? So it partly depends at this point what we. So clearly, if we vote, if we're looking for P, this would be P's highest. If we're looking for Q, one of these is Q's highest, but we don't know what it is. But we don't want to pick one or two. One way to think about this is looking at 1800 versus 1200. 1200 times 0.7 or 1800 times 0.6. One way to think about this is that 1800 is half again the size of 1200, right? So if we think of this as, hey, that's 1200 times 1.5 times 0.6. I say, ooh, what's going to be half again of that? Oh, is this weird to anybody? I'm just saying 1800 is 1.5 times, 18 is 1.5 times 12. So then I can say, hey, that's 1200 times 1.5 of 6 is 9. Ooh, that's a lot bigger, right? So Q's highest is number 5. So now we know it's not 4. The other thing what we're doing here, again, is cheating off the answers. We're playing king of the hill and say, okay, which is the best? You know, if this one is bigger, can I get a bigger one than that? Can I get a bigger one than that? Now, do we know who got the actual greatest number of votes? P or Q? Can we tell? Let me erase all the marks we made on here. Oh, did I say 5? Some people are sorry. Yeah. Sorry, I contradicted exactly what I just said. See what I was saying? When you make mistakes, the better you have an estimate, the more you catch them. I made a mistake. Now here, my estimate didn't save me because I reversed it. But if I then compare it to my work, I might at the final reckoning go, wait a minute, oh, that's not what I wanted. So we can always mess up. We do it all the time, right? So yeah, sorry, number 4 is Q's highest. It's number 5 that we don't want. So a lot of you are saying Q1. Well, how do we know? Well, it's interesting to look at the ones, and we'll see this with averages too. We don't care about the ones where they split 50-50, right? Okay, they're tied. They're tied. So then I'm going to look at where does Q pull ahead and where does P pull ahead. Look where P pulls ahead. P pulls ahead in the small district. Q wins the big ones, right? Look at a presidential election, right? If we're tied in most of them, you know, that's not really a thing, actually. I guess the states are all red or blue, right? But if we're tied in general, you and I have equal numbers of electoral votes, right? And, you know, you win Florida and California, and I just win, you know, New Hampshire. Sorry, like it looks like I lose, right? Because you're winning bigger districts, right? And that's what we've got here, right? Q wins in the bigger districts. So Q wins, right? Since it's tied elsewhere and only loses in one small district, right? So we know that the answer has to be 4. Okay. Christian, how do you guys feel about that place value shifting I was doing at the 0.6 and 800? Was that familiar? Have you done that before? Is that something that that you feel comfortable doing? See in a mix. All right, let's do one more problem where we can think about that a little bit. Second here. See what you make of this one. And again, I'm just going to give you 30 seconds. Okay, what are the best answers here? C or D, C or D, C or D. Agree, agree, agree. So why C or D? We can argue about whether it's C or D. That's fine, but it looks like everyone's agreeing that it is one of those. So why C or D? How could I know that within 30 seconds? Well, sure, if C or D is right, then A or B are too small or E and D is too big, but why? I'm going to say number of digits, but how do I guess what I'm saying is like, teach me, tell us something. How could I tell whether it's more like A, which is 4 digits, or more like, E, which is 7 digits, or something in between, right? We all seem to agree, or at least everyone who answered agrees. Um, so we know that to convert from seconds to hours, we say, all right, so okay, 18.5, whoops, 18.5 miles per second is going to equal 60 times 18.5. Miles per minute. And that's going to equal 60 times 60 times 18.5 miles per hour. And sometimes it helps to verify that for sure. And what I mean by that is to say, wait, am I doing this backwards? Now, thankfully, there's none that are much smaller. Otherwise, I'd have to think about if I were dividing. So if they, for instance, had said, if they wanted us to convert from miles per hour to miles per second, we'd say, okay, it should be more, that should be less, right? So here I could say, if it goes 18 miles in a second, it's going to go a lot more in an hour. So we don't want to divide by 60, we want to multiply, right? So obviously doing 3,600 times 18.5 is a little difficult to do without a calculator, right? But Raimundo is saying, hey, I know the number of digits, right? I've got a 2-digit number times a 2-digit number times a 2-digit number. Or I could say I've got 3,600 times 18.5, right? I could be forgiven for thinking I need 6 digits, I think. Someone could say, hey, 20 times 20 times 20 or 6 times 6, maybe that's 6 digits. I don't know, 222. 5 doesn't seem crazy. 7 seems too much, right? So that's one way to think about it. Another way is to roughly do it. What if I said, well, roughly 20 times 60 is 12 with 2 zeros on the end. And then if I do 1200 times 60, again, I can throw the zeros on and just do 12 times 6, and then times the 3 zeros. So I could do, hey, that's 72,000. Now that's too big. And we know it's too big because we rounded up, right? 18.5 is less than 20, and that matters a lot. If we wanted to find it exactly, we could multiply 72,000 by 18.5 over 20, but that doesn't sound fun. But we know then that, okay, if 72,000 is too big, we definitely know this is wrong. But if we know these are way too small, it's not even half of 72,000. It's got to be pretty close. So C or D definitely makes sense. Now, if we want to find out exactly, we can do all the math. But another thing we can do is, again, play with the digit calculation. So I could say, wait a second. So hold on, let me not give up on the 60 times 60 times 18.5 thing. What if I said, all right, first off, let me do 60 times 6 times 185. See what I did there? I just traded. I said, I'm going to take away a power of 10 here, and I'm going to put one in here. That's not changing the value at all because I simply multiplied one number by 10 and divided the other number by 10. Yeah? Now here's where it gets interesting because I now have 3 numbers and I don't want 3 numbers, I want 2. But I don't really want to multiply 185 times 6 or by 60 because I don't know what that is and that's going to take me a long time and I'm in a hurry. I've got things to do. So here's what I might do. And again, you might find this a little weird, but bear with me. I'm exposing you to new stuff here. Maybe new stuff. Is what if I just double 185 and say, all right, well, hold on, let's see. So I know that 185 times 2 is going to be easier to do. That's like 18 times 2 is 36 and a half, and it's 37, right? I could do that kind of thing. So then I could say, 60 times 3 times 370. I promise I'm going to redeem this in a second. I could say, all right, well, I don't really care about my zeros, right? Don't really care about the zeros. I care about the significant digits, right? And so if I look at 180 times 370, when I multiply that out, where am I going to see my first non-zero digit, right? Well, the zero's there, 0 there, 0 there, okay. But then I'm going to have, 7 times 8. That's 56. And as soon as I know that, I know my first significant digit, my dog's very excited about this reveal, is going to be a 6. Okay. Now, if you think that's absolute insanity, there are ways to do that a little faster, a little easier, right? So for instance, I could say, 60 times 60 times 18.5 is 3,600, as we already figured out, times 18.5. And what if I just trade a 2? What if I just say is 1,800 times 37? Everyone with me on that? I just did the 3,600 like a lot of you already did, and then I just chop one in half and multiply the other up. Now I can do the same idea much faster. I could say, hey, 1,800 times 37, whoops, what's the very first digit that I'm going to have other than a 0? And this happens a lot on the GMAT. I've even seen problems where it's really not possible to find out what the answer is. All you can find out is what the units digit is or what some digit in the problem is. So I'd say, okay, 7 times 7 times 8, 56, right? 0, 0, and then I have a 6. And everything else, right, when I do the next line, I do 3 times 0 and 0. I'm going to have too many zeros over, right? I'll have a 0 here and then 2 more zeros. So it's going to look like this. So all I need to know is that 6. So all I'm getting at here is we're looking for ways other than just doing it all the way out that we can solve these. Now, what I'm going to suggest to you, some of you, I'm hoping are inspired and refreshed and are going to, taking away all sorts of great tips. And some of you are going, oh, please, I'm good at math and these were really hard and it's so much easier to do it the way I already do it. However, those of you in the second category, I'm going to challenge you to do some of this anyway. First, because I think it just makes you stronger. It gives you a better relationship with the numbers and what you're seeing on this test. Second, in a lot of cases, we need to practice doing things that are a harder way to get to the point where it's even an option, right? If that makes sense, right? Think about if you're used to walking places and someone said, yes, you drive. Well, initially, that's terrible. You say, walking is so simple. I just go. Driving, I have to study and to get a driver's license and a car. I have to get gas and I could crash and all these things. But long term, there are cases where driving is going to get you someplace where walking can't, right? Not practically speaking anyway. Right? There may be that initial learning curve or that initial difficulty, and there may always be things where you choose to drive and to walk instead of drive. And in fact, you may always choose to walk instead of drive. You may never want to drive at any point, and that's your right as long as you can do what you need to do. But if we can open up those possibilities, just like with plugging in numbers, working backwards from the answers, setting up charts, sometimes there's a learning curve or it feels awkward. And if you're the type of person who just knocks out a 48, 50, 51 quant without any trouble, then you may not need to do any of that. But for most students, even the ones who are doing very, very, very well, even doing this, a fifth of the time can mean they pick up those extra couple questions that they need to get the score they want. So something to think about. Anyway, I hope this was helpful for everybody. Curious if you at this point have any takeaways that you want to remember. Anything that stands out to you that you want to remember for the future? Valentine's Day and St. Patrick's. Yes. Those are great, right? I can't say I made them up, but they're a great way. And I find the corny mnemonics are the best because they stand out in our memory. Estimation can save time, absolutely. And help you catch errors, right? Great, Nikki, glad it was helpful. It can help if you're unsure of the answer, right? So estimation can help with certainty, right? Either whether I don't know how to do the problem at all, or I think I have it, but does it fit my estimate? Does it make sense, right? So a few techniques that we talked about. Compare to a simpler number. Look at, higher or lower. Is this less than 1/2 or more than 1/2? And what effect does that have? Round numbers and remember which way you rounded, if it was consistent. Sometimes it helps to round in two different directions. I round one number up and one number down, so it balances out a bit. But ideally, we know again with the high-low whether we're above or below what we want. Cheat off the answer choices. Go back and say, hey, what do I see in the answer choices and what's reasonable, and can I work with there? We can do what we call king of the hill, which just means compare one choice to the other and keep knocking off the lower choice if we're looking for a maximum, right? If we're looking for a minimum, it would be the opposite. Okay. All right, Justine. Yeah, thanks for getting up for us in your time zone. All right. And then don't forget that you can trade decimal places or factors to simplify calculation. And you can use units, digit, or other significant digits to rule out choices. Great. All right, folks. Well, I hope this is really useful for you. And if you do want to take any of our courses, there are plenty of options coming up. So check out our website for that. Hope to see some of you around. But everyone, best of luck with your GMAT. Hope everything works wonderfully for you out there. And get in touch with us if there's anything we can do for you. Have a great day, night, morning, whatever it is for you. And best of luck to all. Good evening from California. All right, everyone. Thanks.